Hi, my name is Neil, and today we're going to be talking about esters.
What the is that?
But first, what exactly is an ester? An ester is basically the product after the reaction between an alcohol and a carboxylic acid. So right here we have an alcohol, and right here we have our carboxylic acid. The alcohol and carboxylic acid undergo a condensation reaction where the ester is produced along with water. These are our two products right here. The OH bond in the carboxylic acid combines with the hydrogen in the OH bond in the alcohol to form water. The leftover oxygen in the alcohol attaches itself to the carbon double bonded to the oxygen in the carboxylic acid. This causes the ester to be formed. So there are two parts to naming an ester. First, you have to identify the oxygen that is a part of the continuous carbon chain that is bonded to carbon on both sides. So this oxygen right here is a part of the continuous carbon chain, as we can see right here, and it's bonded to carbons on both sides, this carbon right here and this carbon right here. Next, we have to start numbering the carbon chains on both sides of the oxygen identified in step 1. So the oxygen we identified was this one right here. So now we have to number this chain and this chain. So in order to do so, we're going to start counting from this oxygen. So it's going to be 1, 2, 3. And it's going to be 1, 2, 3, 4. Okay, so first we're going to name the carbonyl group that's attached to an oxygen with carbons on both sides. So in this case, it's this oxygen right here. So we're going to be naming this group first, and so since it's just an alkyl group, we're going to be calling it propyl because it has 1 carbon, 2 carbon, and 3 carbons in total, and we know that if it's 3 carbons, then it's propyl. Okay, next we're going to be naming the alkane group that is on this side of the ester, and since it only has 4 carbons, we're going to call it butane. Now the full name of the ester is not going to be propyl butane, but instead it's going to be propyl space, and then we're going to take butane, drop the E and add an O8. So it would be propyl butane O8. Okay. So now we're going to be looking at 2 examples of drawing esters. The first one is going to be drawing the full structural diagram of ethyl ethanoate. So to get started, let's draw our parent group first, which is going to be... Okay, so now we have this out of the way. Ethyl in the name ethyl ethanoate represents that there's an ethyl group attached to the single bonded oxygen. So therefore we're going to add an ethyl group right here. Okay, so ethanoate represents that there's another ethyl group attached to the carbon that's double bonded to oxygen. So in this case, it would be this carbon right here. So now we're going to add the ethyl group. Okay, so this is how you draw the full structural diagram of an ester given its IUPAC name. Okay, so now we're going to be drawing an ester given the condensed structural formula of it. Now first, I want to identify key things to notice when you're given the structural formula. So first thing I want to point out is that you want to identify where your parent group is located, and the parent group of a ester in this type of a formula is COO, so it's right here. So it's located right in the middle. Okay, so R represents the alkyl group, which is attached to the carbon, which is double bonded to oxygen. So I'm talking about this R right here. And R prime represents the alkyl group, which is attached to the single bonded oxygen. So I want to point out that this is no different than this. this is basically the molecular condensed formula just drawn out. So here we have our COO, we have our CO and O. And here we have our R prime, we have an R prime here, R here, R here. So it's basically the same thing. It's just drawn, that's why this is called a condensed structural formula, because it's condensed down where you don't have to draw any of this. So as I was saying, this R is basically the alkyl group attached to the carbon that's double bonded to oxygen right here, and this R prime is the alkyl group that is attached to the single bonded oxygen, so this oxygen right here or this oxygen right here. Okay, so given this condensed structural formula, we're gonna first identify where the parent group is, so it's right over here. And now we can identify where R and R prime are. So this is R, and this is your R prime. Now we have this down, we're going to start drawing it. So first we're going to start with the parent group. So since this is a line structure, we don't really have to draw the carbon that's supposed to be here, so it's okay. So now we know where R and R prime are supposed to go. So since R prime is a carbon which only has one bond to hydrogen, we would know it's an isopropyl because the other two bonds, they would have to be satisfied with two other carbons. So we're going to draw our isopropyl. Okay, so since this is just an alkyl group consisting of 4 carbons, we're going to call it butane. And since we already have 1 carbon already here, we just need 3 more. So 1, 2, and 3. And since we now know that this part of the ester is an isopropyl and this part of the ester is a butane, we're going to name it using our IUPAC rule, and we're going to call it isopropyl butanoate. Esters have many uses in both the living world and industries. Esters, called parabens, are used as fruit and drug preservatives because they can prevent the growth of microorganisms such as molds and yeast. Furthermore, esters have a sweet, fruity smell to them, and they have a very low molecular mass. Their properties make them suitable for the preparation of cosmetics and perfumes. The lower the molecular mass is, the stronger the odors they carry are. These esters are also used as food additives to improve the flavor and smell of processed foods. They are listed as artificial flavors on labels of processed foods. Okay, so esters can undergo a hydrolysis reaction where the ester plus water produces an alcohol and a carboxylic acid. Okay, so this happens because the ester molecule breaks into 2 halves. So now, if it's broken into 2 halves, this oxygen and this ethyl group is on one side and the rest is on the other side. Okay, so this oxygen needs 1 more bond because it already has 1 with carbon, so it snatches this hydrogen from water with it, so it forms this alcohol, which we're going to call ethanol. And now, since this carbon needs 1 more bond, there is an OH bond that attaches itself to the carbon right here, and therefore we get our carboxylic acid, which is right here. And this carboxylic acid is 3-chlorobutanoic acid.